Bismillahirrahmanirrahim. Assalamualaikum and hello. Okay, today I will present about introduction of our topic. Our topic is Gauss elimination method. And this is my group member Muhammad Nur Sharin bin Azhar, Nurisa Khadijah binti Hasrin, Muhammad Abdul Rizak Yusuf, Siti Nur Afika binti Abdul Malik, and me, Ramsa bin Alam. Okay, this is our introduction. This project describes the use of numerical method in civil engineering by creating a problem statement that must be solved using any numerical method. Our group decided to use Gauss elimination method based on the problem statement that we got. Gauss elimination in linear and multilinear algebra, a process for finding the solution of a system of simultaneous linear equation by first solving one of the equation for one variables in terms of all the others, and substituting this expression into the remaining equation. Our objective is firstly to solve about the problem related to civil engineering field using Gauss elimination method. Secondly is to find the maximum stress in pipe of water distribution system, which is in compound cylinder.
I will be presenting about our group problem statement, which is first I will talk a little bit about the introduction to the problem. Firstly, our group problem is related with civil engineering field where the compound cylinder used as water distribution pipe. Our problem needs us to find the hoop stresses inside radius of outer diameter of the compound cylinder, where the hoop stress is one of the important characteristic needs to be determined in order to planning process of designing the appropriate pipe for the water distribution system, where the failure due to this stress could result in pipe splitting into two halves and also rupturing perpendicular to maximum stress. That is because it is very important to make sure that the stress of the internal pressure is greater than the pressure of the water passed through it. So for this problem, the method that are related to the subject that we already learned in numerical method is Gauss elimination method. So Gauss elimination method being applied in order to find the maximum stress of the compound cylinder. The main idea by using this method is in order to reduce the effort in finding the solutions by eliminating the need to explicitly write the variables at each steps. Next we jump to the problem question, which is we need to find the maximum stresses, where the following four simultaneous linear equations need to be solved. Here, the Gauss elimination method being applied in order as we already mentioned, in order to reduce the effort in finding solutions by eliminating the need to explicitly write the variable at each steps. Another data that will be given in our problem is in this compound cylinder pipe. The inner pipe has an internal radius of 127 mm, outer radius of 165.1 mm, and the internal and outer radius of outer pipe are 165.1 mm and 203.2 respectively. Another data that has been given is the value of E, which is 207 gigapascals, and the value of V is 0.3. And the hoop stress in the outer pipe is given by the formula or the equation below. After we find the value of C1, C2, C3, and C4 by using the Gauss elimination method, we just subs all the data into the hoop stress equation.
Hi, my name is Siti Nur Afika binti Abdul Malik, matrix number CF200031. So next, I will present about our calculation or the result of our project. This is the simultaneous equation that we use in the project to get the value of constant. So generally, by using Gauss elimination, we will need to reduce matrix A, which is over here, into the upper triangular matrix, like this, using the appropriate row operation, and at the end we will use back substitution to get the matrix solution. And after that, substitute all the required values into the hoop stress formula. So firstly, we will do the row operation on row 2, row 3, and row 4. The equation that we need to reduce row 2 is negative A21 over A11 times by row 1 plus row 2. We will get the new row 2 value, which is A21 is 1.0886 times 10 to the power of 6 divided by 1.0886 times 10 to the power of 6 times row 1 plus row 2. So we get the new equation here. So from this equation, we will substitute the value from here into the formula, and we will get this new row 2 over here. So next is reducing we will do the row operation on row 3. The formula involved is negative A31 divided by A11 times by row 1 plus row 3, which is negative 0.1651 divided by 1.0886 times 10 to the power of 6 times row 1 plus row 3. So we will get this new equation. From this new equation, we will substitute the value over here to the equation, and we will get the new value of new row 3 over here. And for the fourth row, since the place here is already 0, so we can skip this step and move to the next step. So step 2, we will do row operation on new row 3, and new row 4. The formula used here is negative A prime 32 divided by A prime 22 times by row prime 2 times row prime 3 to get the new row 3 values. So from here, negative 7.4558 times 10 to the power of 3 divided by 9573 times row 2 plus row 3. We will get this new equation, and from this equation we will substitute the value here into this formula, and we will get the new 3 over here. And next, we will do the row operation on the 4th row, but then this over here is already 0, so we can skip this step and move to the next step. So the last step, we will do row operation to make this place over here become 0. To read the formula we use is negative A prime 43 divided by A prime 33 times by R prime 3 plus R 4. So from that, 1.0886 times 10 to the power of 6 divided by negative 0.6827 times row 3 plus row 4. So we get this new equation. From this equation, we will substitute all the value here, the value from row 3 and row 4 over here into this equation, and we will get the new row 4 values. So as we can see here, we already reached the final objective, which to make the matrix A before this became upper triangular matrix. Thank you.
Hello everyone, my name is Muhammad Abdul Razzaq. Today I'm going to present our part. My part is step 4, the back substitution. So we're finding for C1, C2, C3 and C4 we're using for Gauss elimination. So you can see the slide already. We get C1 is equal to minus 9.2236 times 10 minus 5, and C2 is equal to 4.2618 times 10 minus 3, and C3 is equal to 2.8547 times 10 minus 4, and C4, the last one, C4, so we get 0.0339. So you can see the slide already. We get the solution of the matrix. You can see C1, C2, C3 and C4. We move on to the next page. That's step 5. Hope straighten the inside radius of the outer cylinder. So you can see formula of the substitute. A we get C3 and B we get C4. So you can see C3 2.8547 times 10 minus 4, and also you can see C3 C4 0.0339 until to get 1.9811 times 10 power 11 Pascal, and the last answer is 198.112 GPa greater than 482 kPa. Thank you.
So for the conclusion, we can see that civil engineering field that have some cases required to the numerical method to calculate the related parameter. So obviously numerical method help in finding the exact solution of many non-function which cannot be solved by using analytical method. So for example, numerical method can provide an alternative solution which will ease the process of calculation and also help the engineer to solve the cases related to civil engineering field in shorter time but with accurate result. So that's all from me. Thank you.